not sponsored, but if you need to bake literally anything, sallysbakingaddiction.com. Like, genuinely great recipes. They don't have a random feature, but I kind of wish there was a button I could click to just give me a random recipe, because sometimes I don't know what I want to make, but I want to make something, and I've literally never had a miss with this website. So let's say I picked a couple dozen random recipes from this website and I categorized them in 2 ways. First, I checked to see if it was a dessert recipe or a non-dessert recipe, and then I also checked to see if the recipe involved chocolate or not. I could take all that data and put it in a 2-way table, something like this, which we've seen before, add in the totals, and now I have a really good summary of the 36 recipes that I found on the website. Now let's say I'm going to randomly pick one of the 36 recipes that's represented in this table. What's the probability that the recipe I randomly select is a recipe that involves chocolate? Well, I'd have to count up the total number of chocolate recipes, which in this case looks like it's 14, and then divide that by the total number of recipes in the table, so 36. For the sake of simplicity, let's just leave fractions unsimplified. Let's not deal with percents and decimals. It's just 14 over 36. When I said in words, what's the probability that a randomly selected recipe is a chocolate recipe, I could have converted that into symbols like this. A lot easier to write. So here's a couple follow-up questions just to get your mind thinking about 2-way tables again. Why don't you pause and try finding those numbers yourself? You can leave the fractions unsimplified. Okay, so again, this is not anything new. We've done this before, way back at the beginning of this course. Let's compare 2 of these numbers. The probability that a randomly selected recipe is a dessert recipe and the probability that it's not a dessert recipe. You will notice that these 2 fractions add together to equal 1. The probability that a randomly selected recipe is dessert or not dessert is 1. It's 100%. It's guaranteed. If I pick something, it's either going to be dessert or not dessert. There's no third option. So the events dessert and not dessert would be considered mutually exclusive. That means they cannot happen at the same time. There's no way for me to pick one recipe that is both a dessert recipe and not a dessert recipe at the same time. Another example of mutually exclusive would be, like, let's say I'm going to randomly pick a student from my school. The events, the student is a senior and the student is a freshman, mutually exclusive. It's impossible for me to pick one kid who is both a senior and a freshman. Now, if the 2 events are, is a senior and has a driver's license, those would not be mutually exclusive, because I could pick one kid who is both things, both a senior and the holder of a driver's license. So mutually exclusive just means they can't happen at the same time. Okay, so we said the probability of picking a dessert recipe is 21 out of 36, and the probability of picking a chocolate recipe is 14 out of 36. What's the probability of picking a chocolate or dessert recipe? Well, to answer that, I can look at the table and just find every spot that's either chocolate or dessert or both. So adding those up, that's 23 out of 36. Now, what's weird is that 23 is not 21 plus 14. You might have thought at first that dessert or chocolate, we would just add the dessert probability to the chocolate probability. The problem is, if we add dessert and chocolate probabilities together, we're double counting all the recipes that fall into both categories. So if I just take 21 and 14 and add them together, I get 35. If I subtract 12, that overlapping section, then I magically get 23. This is the general addition rule of probability. The probability of A or B is just the probability of A plus the probability of B minus the overlap, or probability of A and B. So in general, if you're doing a probability question and they're asking about an or scenario, you're going to be adding probabilities together, but you have to be very careful to not double add the overlap. So let's just do another example. What if I want the probability that a recipe is in the other category or a chocolate recipe? One way I could do this is add the total for other, which is 15, the total for chocolate, which is 14, that's 29, and then I could subtract the overlap, which was 2. So 29 minus 2, that'd be 27 out of 36. The other way I could do it is look at the 3 cells that are chocolate or other or both, and that'd be 12 plus 13 plus 2, also 27. Yeah, also 27. I can count. So that's the general addition rule. It's got a fancy name for something that is kind of straightforward. Just basically or means and. Oops, no. That's or does, no. Or means add. If you see or, you're going to be adding. Or means and. That's, I don't know what that was.